Have you ever played with bugs? Maybe you put down a twig or a leaf to see how it would get around that obstacle. Let's do the same thing in Python. Python example 6. Here, the bug is this little soldier, and he's trying to get to this hole. I've made this interactive pathing simulator so that we can play with him. Alright, let me tell you the controls. If you press the N key, he'll path one more step. The white box is where he's currently planning to go, and the blue boxes indicate where he's been. Of course, the pathing stops when the white box reaches the destination. You can reset things with the I key. You can paint obstacles on the map with the left mouse button. And you can path more quickly. Instead of having to press the N key over and over again, you can press spacebar and it'll go as fast as it can. Oh, interesting. We can save the map by pressing S. We can clear the map by pressing C. And we can load the map by pressing L. The map files are available for you to use. Simply go to Users and map2.txt, wherever you've got your example located. This map is stored the same way our other maps are, just as a JSON object, which you can load using json.loads into a 2D array. So if you wanted to, you could load in a map that you generated from an earlier lecture to use as a pathing simulator here. Okay, let's talk about how the bug is getting from place to place and bother him a bunch more as he tries to do so. We'll clear the map and reinitialize pathing. Then I'll press the space bar so that he's not already going, and reinitialize the pathing again. This time I'll give him a really annoying sort of barrier here. Maybe like this. Okay, that seems pretty good. Then I'll press space bar. The way this kind of pathing works is our character moves directly toward the goal until he hits an object, and then he follows the object like a person in a maze. For example, keeping his left hand on the wall as he goes. Let's look at it step by step using the N key. Okay, he's hit a wall and he's following it with his left hand on the wall. Under what conditions does he leave the wall? Certainly, if he were to stay on the wall, he would just orbit around and never reach the goal. He'll leave the wall whenever he gets to a point which is closer to the destination than when he started. This can sometimes produce unwanted results. Imagine I had a wall right here. Okay, let's make this wall really big and annoying. Okay, like this. And then there's another wall here. Okay. So we've made the map even more annoying for this poor bug. We'll reinitialize pathing and use the spacebar to path around. He's following the wall, and then at some point, I'll use the N key. He's exiting this following mode, and he's headed straight toward the hole. But because there was an obstacle here, now he hits this obstacle, and he'll have to path around it. Oh, but he pathed around it quite easily. He went around it, and then at this point he was closer than when he started. He exited, and he went into free mode. So there you go. It was actually not too hard, and he didn't have to do all this extra stuff. You might say, looking at this path, that it's so inefficient. Why would you even bother? Why wouldn't you use a more smart pathing algorithm that finds the way directly to the hole and forgets about all these other routes? The thing about this pathing is that it's very computationally cheap. At each step, the character need only consider his immediate surroundings and whether he's gotten any closer to the hole than he was when he started. So in that sense, it's very computationally efficient. And by applying a refinement, we can actually make the path pretty good. What do I mean by that? Well, it wasn't a mistake that I left the character at the beginning of the path. I did that to show the idea that he's only imagining himself headed in that direction. Let's pretend now that instead of a bug, this is a human being. and he's just pretending and seeing which way he would go if he were a bug. Then he can try to take shortcuts. And I've made a little algorithm that applies shortcuts to a path. The way it works is, when it tries to make a right turn, it tries to make the turn earlier, because that would shorten the path. And that's all it does. So let's press the refinement key, R. Already it's cut away this big loop over here. Anytime it sees a loop where it doubles back on itself, it simply deletes that part, because it doesn't make any sense, if you're trying to go the fastest way to a location, to keep going around in circles. So it cut that piece off, and here it made a right turn a little sooner. Here where it makes this right turn, if I press the R key again, it will make that turn sooner. By continuing to press the R key, I find quite a fast way to get to the end. And it was very computationally efficient. At least, so I say. So you see that bug pathing is a way to get from a destination to a source, or the other way around, and that you can apply refinements to the path to make it not too bad. In the next video, we'll look at how this example was made, and we'll look at more details of bug pathing itself. See you next time.